Adelante, doctor Hartmann.
Okay, thank you very much. Well, welcome everybody. It's a pleasure to be invited to tell you something about a course that I've been giving for a long time with great pleasure. And I just hope that people will adopt this methodology at other universities because I think it's very useful and very versatile. Um, just for your information, I have actually been to Chile twice because in a previous life I was an astronomer and I have observed at La Silla Observatory twice in the past. So it was very, very nice. And I've also traveled through Chile and to Bolivia and Peru. Um, so it was always a great pleasure to be in Chile. But now I'm at the University of Delft, Delft University of Technology, doing something completely different. And I'm happy to give you a flavor for what I'm doing. So I'll start sharing my screen. Let me see. This should do it. I think. Can everybody see this? Okay. If I don't hear any complaints, then okay. Now I can only see my presentation. I can't see any one of you, but I have my chat on. Um, it's my style to have a very highly interactive style of presenting, and of course, in this current situation with video, that's very difficult. But I'll try anyway. And also, this presentation, I have a few questions for you, so I don't envy our interpreter who has to translate my words and then maybe even translate the answers. So we'll just see how it goes. Anyway, we're going to talk about turning technology into business. And that is basically that I'm using university patents in my education to stimulate technology-based entrepreneurship. Let me see. How do I get to the next slide? Yeah, here we go. So at most universities like Delft University of Technology, we have three main activities, three pillars on which we build our university. And that is research, education, and more over the past 10, 20 years, entrepreneurship. And I try to connect these three pillars because research, especially at a technical university, leads to a lot of new technology. And in many cases, this technology is patented. And I use these patents in my education, in my courses, in the course Turning Technology into Business. And in some cases, this will lead to students starting their own company. So that leads to entrepreneurship. I mean, there's many different kinds of entrepreneurship. We like to focus on what we call technology-based entrepreneurship, innovation-driven entrepreneurship. I mean, if you want to start a restaurant or a hair salon, that's entrepreneurship too. But as my colleague from the MIT Center for Entrepreneurship used to say, you didn't come to MIT to start a fruit stand. You probably came to MIT to start a business using new and advanced technology. Okay. But if you know anything about entrepreneurship, you might go, wait a minute, if you start with technology and you push it into the market, that's the classical technology push mechanism. And real entrepreneurship starts the other way around. It starts from a market need, and then maybe technology is the solution. But in reality, entrepreneurship is just trying to get it a good match between your technological competencies and societal needs. And it's an iterative process where you try to create a match. And if society wants something slightly different, then your technology should adapt, and the technology is then being steered by societal needs. So it's not strictly technology push, although that is in this course the mechanism that starts it. So I'm using patents from TU Delft, patents where university research has been codified. It's a document and it's been protected. And I give this course to what I call master level plus students. That means they're at least at master level, but in some cases, they're even PhD students. And I also invite TU Delft researchers to participate in this course. One of the most important aspects of this course is that it's multidisciplinary, which means that all the students from all the faculties can participate. It's important to have this mix of different competencies. And of course, they come from different countries, from different backgrounds. So there's a whole lot of different inputs, which is very important for the creative process. And the other thing that I demand from the students is full commitment. You have to attend all the courses. You have to participate in a group and work on a patent. And I cannot allow, because the course is very popular, so many more students want to follow it than I can admit. So I cannot admit what I call tourists, students who just want to sit in the back and listen. You either participate fully or you don't participate at all. And I'm using patents from the TU Delft, and I have three conditions under which I will select the patents. First of all is versatility, which means that it's not immediately clear what you can do with a patent. I mean, if it's a patent to make ammonia, then basically the only thing you can do with it is make ammonia. So that's not very challenging in the creative dimension. But in most cases, patents will be very versatile. You don't know exactly what you can do with it. The second requirement is that the inventor likes it, that we work with his or her patent, because the inventor involvement in the very beginning is very important. Maybe there's already a prototype, maybe he or she already has some leads in the industry, so the inventor involvement is crucial. And the third requirement is that the patent is available, that in the case that students think of a very nice application and they have the will and the willingness and the capability to start their own company, that they can use this patent, that they don't get to hear, well, we're very sorry, but this patent is not available. We sold a license to Philips or to some other company. So we're working with patents, and I don't know if you've seen patents before, but patents are special in a way that they use a kind of language that is not every day. So as an example, look at this object. I mean, most of us would describe this object as a long drink glass. However, if such an object is described in the patent, it's most generally not described as a long drink glass. So here's a question to you. Does anybody want to attempt telling me how this object might be described in a patent? Take a guess. Anybody? Okay, I can't hear anything. Maybe somebody is trying. Cylinder. Oh yeah, I can see it. Cylinder recipient, liquid holder. I see. Okay, good attempt. The trick is to describe such an object without being too specific as to the details, whereas try to make the description as general as possible. So I mean, there's no good or bad or wrong answer here, but this might be how it's described in a patent, as a one-sidedly closed, transparent cylindrical object. And that's what it is. But specifically, it's made out of glass, but glass is too specific. So you try to get your claims as broadly as possible. Okay, one uh, other example. Who wants to try his or her hand at this one? You and I would call this a tea kettle, a whistling kettle. How might this be described in a patent? Okay, I'm watching the chat and I'm listening. Something that makes you run to the kitchen. Yeah, that's good. High pressure tank. All right. All right. Well, the trick is to describe the function rather than the shape. So what is it? What does it do? And what is it used for? And again, there's no perfect answer, but it may be described as something like a liquid heating apparatus augmented with an audible notification device. So you have to know that that's a whistling kettle then. So the first step is for us, if students read a patent, to try to make sense of what the patent does. So we need a way to describe a technology. So what is technology? And we could go into discussions about definitions and you know what's written in dictionaries. But I like to use a very pragmatic description. I just tell the students, read your patent and then complete this sentence. With this patent, with this technology, we know how to complete the sentence to describe what the essence of your patent is. And I'll give you an example. This is something everybody is familiar with. It's a paperclip. Um, as you can see, the title is metal wire paperclip structure. Maybe you didn't know that a patent existed, but there it is, and with a drawing um, showing the very familiar shape of a paperclip that we know. And now the assignment is with a paperclip, with this technology. It's very simple technology, but still it's technology. We know how to. How would you complete this sentence? Okay, let's see if I get some suggestions in the chat. It's okay if you can also speak out. I don't know if I'll be able to hear you or whether it goes through the interpreter, but
Quizás sabemos cómo sujetar papeles.
okay, it's very good. And in the chat, I see somebody who says hold documents with a non-intrusive object, which is very good. Which is actually put papers together without glue. Very good. Um, so it could be something indeed like hold sheets of paper together, and then paper in parentheses, because it could be any kinds of sheets. I mean, we're mostly used to paper, but the technology is to hold sheets of something together, and then with maybe the addition in a reversible, non-destructive way. I mean, you could also staple them together, but then you have two little holes. And that's, you know, if you remove the staple, it's not in the same condition as when you started. With a paperclip, you remove the paperclip, you know, you started, you return to where you started from. So hold sheets of something together in a reversible, non-destructive way. That's the technology of the paperclip. Now, I usually show this to my students as well, because a means of accomplishing something is by no means unique. I mean, these are all kinds of paper clips that have been invented, and we're not going into a discussion whether or not this would violate the original patent, but the lesson that you should learn is, once you find a very nice solution to a problem, other people will find other ways to do the same thing, invent around your solution, and try to establish, you know, to get part of your market share. Okay, now this is something, this is from an actual patent at TU Delft. Now I'll read the abstract just to show you what kind of language is being used. Okay, and I don't envy the translator. This is going to be difficult for you. I'm sorry. So the invention relates to composite pressurizable structures which are overwound with fibers or are braided. The pressurizable structures comprise axial sections, which in turn comprise both concave and convex surfaces. The shape characteristics are related to geodesic as well as non-geodesic trajectories in regard of the fibers. Axial sections of the pressurizable structures can be rotated, expanded, or bended with respect to the longitudinal axis of the pressurizable structure. Now, how could you make sense of this? So my question is, very quickly, is there anybody who has any idea what kind of technology this is? What is described here? Any ideas? Tires. Well, that's a good suggestion. Might comes close to. Okay, one other suggestion. Tubeless tires, maybe, or something related. Well, it's a good guess. So this was from an actual patent that students worked on. And this is the front page of that patent, and it already shows you some of the images. So it's tubes braided from fibers. You can make them as long as you want, and you can vary the diameter. So you can make these blobs in any shape or form, as long as they're around the vertical axis. That's the kind of things that you make with it. And actually, a company was started, Technische, and here you see some of the robots that they employ to make these structures. And it's a whole different story. I mean, there's no time to go into it here. I have another example for you in a minute. Who needs these structures? What you can do with them. Now, the methodology of this turning technology into business is first you express your technology as we know how to. You complete the sentence. Think of the paperclip. Think of this, these tubes. Then you try to find many different applications. Who needs this? What markets can you find that needs the application that you can think of? And then you have to think of the value drivers. What makes your technology special in these applications? And on the basis of that, you select one promising application, one market that you think you should start with as applying this technology to. Then within that market, you identify potential customers. Who wants to buy your solution, you think? Then you select what you think is a promising first customer, a launching customer. And then you get out of the building and talk to them. You actually visit them and talk about their problems. You cannot find these answers by staying in your office and going online on the internet. You really have to talk to people, and then they'll tell you, what they really need. It's a very, very important aspect. Okay, here's one example of a company that came out of this course, Turning Technology into Business, Ampelman. It started with this. Normally, I would ask the question, is there anybody who knows what this is? But I'll give you the answer now. This is a flight simulator. And not one of these flight simulators that you might have on your computer, which is just a screen and it shows you the horizon and the instrument panel in an airplane. It's a real physical object. It's big because you can see here the size of the door. So people get inside of this flight simulator. They operate the instruments, And then the flight simulator will move as a real airplane would, left and right and back and forth and up and down. It's really simulating the motion of an airplane. Uh, and pilots will have to take these trainings here. And every time something changes to an airplane, and especially if a new airplane is being introduced, they need to spend many, many hours in such a flight simulator. So you might complete here's a patent, a TU Delft patent for flight simulators. So you might complete the we know how to in the case of a flight simulator as we know how to simulate motion, specifically airplane motion, but it doesn't have to be for an airplane. With this technology, you can create motion that wasn't there and that you want. You want to simulate in real time the motion. Okay, so that's settled. Now, this guy, Jan van der Tempel, he did his PhD at Delft University of Technology. As you can see, it's about the design of support structures for offshore wind turbines. And he was at a conference and he was thinking about access to these wind turbines. How do you get from a ship onto a wind turbine or maybe even an oil rig platform? And suddenly he got a brilliant idea. He got a brain wave. So he thought if you take an existing flight simulator and turn it upside down, but literally upside down, and also put the functionality upside down, basically do the exact opposite of what a flight simulator does. In that case, you could complete the sentence we know how to into not we know how to create motion, simulate motion, but we know how to compensate motion. And you only want to compensate motion if that motion is unwanted. So with an inverted flight simulator, we can take away motion. Okay. So if we know how to compensate unwanted motion, the next question is, what problem does it solve? Well, it takes away motion, but who has this problem? Can you find industries, people, companies who have motion, any kind of motion that they want removed, that they want to be compensated for? Next, you have to estimate how big is their pain. So how much is what we call the pain relief worth to them? If you can remove their motion, how much money are they willing to give you for this? How big is their pain? Very important. Another important question is, what other choices do they have? Apparently, they manage to operate currently. So how do they do it now? And what is the alternative? And how are you better? So how much is your solution worth to them? And this is very important, especially to students at a technical university. It's very difficult to make them understand this part, that they should not talk to engineers. I mean, we train our students at the University of Technology to be engineers. And of course, the most likely people that they want to talk to are other engineers because they speak the same language and they understand what they're saying. But engineers don't control budgets. Engineers don't have any money. So you can talk forever about how nice and how clever your solution is. Um, in the process, maybe even giving away essential details of how to do it so that they eventually might do it themselves. Rather, you have to talk to CEOs or CFOs who may be engineers, but these are the people who have the problems that cost them the money. So they control the budgets. So you have to translate your solution into something that's of value to them. And they don't care basically how it works as long as it does work. So in the case of the Ampelman, they looked at 5 different industries and various applications within these industries. For example, they said, okay, maybe the market is with the Navy. What if we can build stabilizing helicopter decks so that helicopters can more safely land on these decks and they're more accessible throughout the year? Or maybe an application is in the oil and gas industry to create a motion compensating platform to transfer people and goods from a ship to an oil rig or a wind turbine. Remember, this was the original incentive to start here. But even though you think that this might be the best application, you have to look at many more applications just to see if you didn't miss any important applications. So they looked at various industries, and the crucial thing is that you also look at, you know, a little bit crazy applications just to cover all bases. So one of the things they looked at is, can we create a cabin on board of a ferry so that people who normally get seasick, you know, don't get seasick because the cabin is being stabilized. Or maybe we can stabilize swimming pools on board of a ship so that when the ship is sailing, the water doesn't slosh out. And they ranked all the applications in 2 dimensions. They looked at the technical feasibility, meaning how good are we with this technology to actually do this? And the second dimension they looked at is the commercial feasibility. Is there any money to be made if we do that? And in the case of the air sickness cabin, they thought they could do this, but there was no money to be made. So the 3 most interesting applications was stabilize helicopter decks, either for the Navy or for the oil and gas industry. And the one that they thought would be the most promising is a motion compensating platform to transfer people and goods. They thought they could excellently do that with the technology, and they also thought it was commercially interesting. So that's the application that they ended up doing. And they applied for a new patent. And if you look at this drawing of the patent, you can just see literally an inverted flight simulator on the deck of this ship. And this is the kind of equipment that they build. You can clearly see the inverted flight simulator connected to a platform, connected to a bridge to transfer people. And this is from their website from a long time ago. As you can see, it's from February 2015. And this was the moment they had on the left bottom corner, they kept count of how many people had made a transfer using their equipment. And in March 2015, they had just crossed the 1 million mark. More than 1 million people had made a transition over this walkway. Then they had a new website, and this counter was gone. So I told them, I need this counter back, because every time I give a presentation, including this one, I go to their website the night before and I check what the new numbers are. So I looked at it yesterday, and they have now crossed the 6.5 million mark. More than 6.5 million people have made a safe transfer from the ship to the wherever they needed to go, the oil rig or the wind turbine. And in addition, they also keep count of how many kilograms of cargo have been transferred. And that's over 16 million now. And I asked them, is this just a rough guess or is this accurate? And they said, no, this is very accurate, because in this industry, safety is so important. Everything is being logged, everything is being counted. So this is very accurate. Okay, Ampelman just came out of a TU Delft idea, TU Delft course, and they now have 13 offices throughout the world, none in Chile, unfortunately, but they have one in Brazil. So they operate all over the planet. And now, of course, you want to know, how does it work? So I have a little video of one of the early prototypes where you can see the Ampelman in operation. So here you can see it's not turned on yet. So the platform together with the ship are moving up and down on the sea that's not at all that rough. Now it's turned on, and you can see that the ship is still moving up and down and back and forth, but the platform is absolutely still, absolutely motionless. So this is what they do. They compensate for this motion in real time, which is a very, very smart thing to do. You can see that this makes a transit a very safe operation. So this is the value that they create in this case. Okay, summarizing. The most important thing for the students to learn is that they need to talk about the solution. They should not talk about the technology. They shouldn't even have to understand the technology. I mean, there's the inventors of the technology who work, the researchers at TU Delft, they understand the technology. If there's a problem, you can always go to them to find solutions. The students need to talk about the solution. They never should talk about how it works. As I said, you may be revealing some things that should stay a secret, but you have to talk about what it does. And that's very difficult for students who love technology and who are engineers. And I give them as an exercise to try to explain how it works to their grandmother. And I realize there are some grandmothers who may have a PhD in quantum mechanics a lot, but your average grandmother will probably not be so tech savvy. So as an example, they need to explain it in language that a grandmother or substituted for your 6-year-old daughter understands, and that's the level, with all respect, that they talk to the CEOs and CFOs. Talk in terms of solutions. So talk in terms of what it does. Never discuss the technology itself and never explain how it works. Okay, so at TU Delft, with this course, I try to connect the research with the education, new technology coming out of the research patents. I use them in turning technology into business, and sometimes this leads to entrepreneurship. But there's also a feedback loop. Entrepreneurship will invariably raise new questions which have to be solved. So there's many examples that I could give you where startups need the help of the university again to solve minor problems in their business. So they go back to the university. Yeah. So there's once you have this entrepreneurial ecosystem, there's a vibrant cross fertility system in place that's very interesting to watch. I've been giving this course now for the 18th time. I'm actually in the middle of the 18th edition. And in these 18 editions, 236 different groups of students have worked on 159 different technologies. So you can see sometimes two groups work completely independently on the same technology. 15 companies have started as a direct spin-off, by which I mean that they use the actual technology that they worked on during this course. And another at least 30 companies have been started by students who took my course, but didn't work on a patented technology that they could turn into a business, but they remembered all the tools and all the ways that I showed them during the lectures, and they found a new technology and they found a new challenge and they applied it, and they started their own company, even though it was with a different technology than the one that they used during this course. So, as I said in the beginning, I think this is a very fruitful way to connect your research, your education, and your entrepreneurship. So I hope that more and more universities will adopt this methodology and do it as well. All right, that was my presentation. Thank you very much. If you have any questions, don't hesitate to ask. Thank you.